Okay, so let's now discuss the fundamentals of mathematics and the need to be pragmatic when obviously doing this most fundamental of sciences. Well, mathematics is something that actually precedes science and is of more importance than science itself, because science cannot be written down without mathematics. So mathematics is like a tool for science, and it's a very fundamental tool. But if you make mistakes at that level, then obviously you compromise your future, because there is formula that are right at one level but then do not apply universally. Yeah. Now, whenever you have formula that cannot be applied universally, you know that there is a problem there. And now I'll break it down for you step by step. We'll start with the differences between a remainder and a total. Yeah. Now this is a fundamental difference, because most people think that when you do subtraction, yeah, that you're getting a total, and when you do addition, you're getting a total. So you view the concept of the total as meaning the same thing. It's not universal. It doesn't mean the same thing. In terms of subtraction, the total, you cannot call it a total. It has to be called a remainder. I'll show you. 4 minus 3, yeah, is 1. And if you say that in terms of spoken arithmetic, you would say something like, when you take away 3 units from where there is 4 units, how many units will you have remaining? Remaining is a key term here. Now, when you do addition, on the other hand, you say 4 plus 3 equals 7, and spoken out loud will be, when you add 3 units to where, where there is 4 units, how many units do you have in total? Total. It's not the same total. One is describing a remainder and the other one is describing a summation. These are not, you cannot say, when you hear the word total, what thoughts are there that are conjured up into your consciousness. When somebody says cold, you think of snow, ice, getting a jacket. When somebody says total, what do you think of? It shouldn't conjure up the same thoughts. Yeah, because slightly different. One's describing a remainder, one's describing a summation. Yeah. Now, hold on. What happens when we operate on 0? I put here, it's a waste of time because all you did was nothing, and I'll show you. Yeah, I'll show you before we get into the mathematics of it. Let me show you a video first of all. This is a video of an experiment I did with hand. Yeah. Just listen. As a demonstration, yeah, of why you must be pragmatic when you are defining the fundamentals of mathematics. I'll give you a demonstration using hand. Now, hand, yeah, I want you to go and count how many coins are on that bench there. Yeah, that bench there. Yeah, okay. You've got to be pragmatic. You've got to deal with what's physically there. Yeah? Good hand. Right, so there's 6, yeah? Okay, good. Now, let me think. Let me take away 2 coins from there. Hand, can you go and take 2 coins from there, yeah? Yes, 2. Okay, good. Right. Okay, now hand. Yeah. How many coins are left?
Yeah? Yes, over there. Mm-hmm. 4. Yeah? Okay,
So
good,
you
good.
you come up
Now,
with a thought to remove
hand,
two
if you go
coins,
and take
yeah,
3
from where there's
coins
6
from there,
and 4 remain.
yeah,
You have taken
and give it
2,
to me.
yeah, and you are
No, no,
left
no, no,
with
not 4.
4.
3. 3. 3,
4
yeah?
remains.
3. Yeah?
Now you remove
Okay.
3.
Right. Right. Now go back and tell me how many are there. Yeah.
That's the total we're talking about. It's a remainder. How many
1, yeah?
remains there?
Okay, good. Now, hand, I want you to go and take 1 coin away from there. Yeah? Yeah, 1. Okay. Okay. Now, I want you to go and count how many coins are there. Yeah? Okay. Yeah, there. Yeah, there. Go and count how many are there.
Now, how
Go on.
many remain?
Right.
How many do you have remaining? Nothing.
Nothing, yeah?
0. 0.
Nothing. Okay, I get it. Now, hand, go and take 4 coins away from there.
Now, if there's
Yes,
nothing
4.
remaining there,
4 coins. From there. Yeah? Yes. Okay. Just do it.
what happens when you try
Okay,
and
hand,
take away
don't panic,
4
don't panic,
units
don't panic, hand, don't
from
panic,
where
don't panic,
there's
don't
nothing?
panic, don't panic. Okay, how many coins did you bring back?
As soon as you attempt to do that, you bring back
You brought back
nothing.
no coins.
So whatever
0,
you
yeah?
attempted to remove
0 coins.
becomes nothing.
How many coins are left there? Yeah, there. Go
and
and count them.
what remains there will still be nothing.
How many? 0. So you've removed 4 coins from there, and there's nothing that remains.
You see?
You've removed no coins from there. No coins from there, and nothing remains. Yeah? Okay. Now remove 10 coins. 10, yeah, 10. Yeah? 10. Yeah? Yeah. From there. 10. Just do it. Okay.
Pragmatic mathematics. It doesn't matter
Okay,
what
don't panic.
number you remove. You could remove a million
How
for
many
racket.
coins are there?
There would be nothing remaining
How many
there.
did you bring back?
And you would have brought back nothing. The number you try to remove
So
becomes
you
nothing.
went to remove 10 coins, yeah? And you didn't bring back anything, and there's nothing left. I rest my case. Yeah, so if you take away anything, 5, 10, 15, 20, anything from nothing, you still have nothing, right?
And you bring back nothing too.
If you take away 1,000,000 from there, yeah, you still have nothing. Yeah? Good hand.
Okay, well done, hand. Right, so let's just go through it mathematically. Let's start with case 1 here. Now, I told you about a law being universal. Yeah? The reason why they came up with negative numbers is because they had missed a universal law. They took it for granted. They didn't know how to deal with 0 and how to operate on 0. When you take a case where you're trying to remove nothing from nothing, yeah? So let's say n is the number you're trying to remove from a place where there's nothing, yeah? So you have nothing, take away n equals 0. If you say that in terms of spoken arithmetic, yeah? So you'll be asking yourself a question is, what happens when you take away nothing? No, when you take away a number, yeah, from where there's nothing. If that number is 0, we all know that 0 take away 0 is 0. And that should be universal. If you can see it anywhere, it should be universal. But they don't call it universal. So basically 0 take away a number is 0. In the case of where that number is 0, we know that to be true. You can do that yourself. 0 take away 0, put it in your calculator. 0 take away 0 is equal to 0. Yeah? So we know that 0 take away a number is equal to 0 when that number is 0. Yeah? And in equation 2, 0 plus a number, yeah, is equal to that number. 0 plus n when n is equal to 0 is equal to 0. Yeah? So this law does not violate this one. Yeah? So if you substitute for 0 in equation 2, so where you see 0, you write 0 minus n. So that's 0 minus n plus n is equal to n, right? So we have 0 minus n plus n is equal to n. Yeah, n in this case is 0. Yeah, which simplifies to 0 equals n. Yeah, so this number, yeah, when you take away this number from 0, it becomes 0. So that even if you add it onto 0, it will still be 0. And that's so whenever you take away a number from 0, it becomes 0. Yeah. Right. So now this is equation 4. So if we use equation 4, and we substitute for 0 in equation 1 and add n to both these sides, we get, so 0 equals n. Yeah. If you put that into equation 1, yeah, you get n minus n, yeah, equals 0, which is true. And then if you add n, it will be n minus n, equation 1, plus n, yeah, equals 0 plus n. Yeah, n equals n, which is also true. When it is equal to 0, 0 equals 0. So that's just like I told you. It's a waste of time because all you're doing is nothing. So now consider a number where n is greater than 0. Yeah, in the case of n equals 1, equations 1 to 4, well, first of all, equation 1 becomes 0 minus 1 equals 0. Yeah, 0 minus 1 equals 0. Equation 2 becomes 0 plus 1 equals 1, which is true. We're doing the case where n equals 1 here. So equation 3 becomes 0 minus 1 plus 1 equals 1. Yeah? 0 minus 1, yeah, plus 1, yeah, is equal to 1. Yeah, which simplifies, yeah, to 0 equals 1. So as soon as you started to take away 1 from 0, the 1 became 0. Now let's go back to what we're doing in society now. Yeah, 0 minus 1 is equal to minus 1, as you know it. Do it in your calculator. 0 minus 1 is minus 1. That's what you know. But according to my new not revolutionary, this is something you also know. You also know that 0 minus n equals 0 when n equals 0. So if this is true, yeah, how can that be true? 0 minus 1 is equal to 0. But here you've got it as 0 minus 1 is equal to minus 1. What are you doing? Yeah, that's where the problem started. Now once you start doing that, you get far. You know, the problem as somebody who's done math, yeah, you get far with the wrong equation. Yeah, but there will be a scenario where it's completely wrong, yeah, because it's fundamentally wrong. Yeah, sometimes I develop equations to explain natural processes, and it appears right at one level. Yeah, it appears right. For example, when you're describing displacement, yeah, when you bend a ruler, yeah, it will observe a displacement, off-center displacement that is linear, if you like. Yeah. But when you have large displacement, when you bend it wider, yeah, or when you bend it farther, it stops being linear. So at small displacements, you could say, yeah, it's a linear displacement, yeah. But at larger displacements, it becomes parabolic, yeah, or some kind of hyperbolic, some kind of curved displacement. Sorry, that's a bit too technical. But basically, yeah, it's not universal to say that when you bend a ruler, it's gonna have a linear displacement. Yeah, because there will be a time when it becomes non-linear. So it's the same, yeah. In terms of describing displacement, we couldn't, yeah, because we had made a fundamental error here. We couldn't even discover a law that describes displacement when you bend a ruler universally, because we have made fundamental errors. This is what creeps in. When you have a fundamental error, it's like having a minus in the wrong place in a source code, yeah, where it should be a plus. Yeah, it might work at a certain level, but there will be a level where it goes off by a long shot. Yeah, because we make this fundamental problem here. Yeah. So equation 5, 0 minus 1 is equal to minus 1, as you know it. Now using equation 1, which is here, we also know that 0 minus n is equal to 0. Therefore, equation 6 can also be written as 0 minus 1 is equal to 0, going by equation 1. So equation 5 is minus 1, that's your case. Equation 6 is 0, to try and make it a universal law. Now substituting 0 minus 1 from equation 6 into equation 5, we have, well, 0 minus 1 is equal to 0. So if we go back to here, it will be 0 minus 1 is equal to minus 1. Yeah. No, sorry. 0 minus 1 is equal to 0. Yeah. So 0 minus 1 is equal to 0. So 0 equals minus 1. Yeah. So you get 0 equals minus 1. Yeah. So minus 1 is the same as 0, because how could you tell me what remains is minus 1 when you're looking at it? When you look at it, what remains is 0. Yeah. So therefore 0 becomes minus 1, or minus 1 becomes 0. Minus 1, when you look at minus 1, you see nothing. Yeah. So any number taken away from 0 becomes 0, because whatever you take away from nothing will always leave nothing behind. Yeah. So the resultant is 0. Minus 1 has become 0. Therefore, equation 7, the root of minus 1 is the same as saying the root of 0, going by this. Yeah. Yeah. The root of minus 1 is the same as the root of 0. But we know that the root of 0 is 0. Therefore, the root of minus 1, which is equal to the root of 0, is 0. Where did you come up with the imaginary number I? Where did you come up with that from? Yeah. The root of minus 1 is 0. And the root of any minus number is 0, because any minus number, we can see here universally, any minus number becomes 0. So the root of any minus number is... Now where did you come up with I, the imaginary number? Yeah? Where did you come up with I? Yeah? Because convention has it that the root The root of -1 is equal to I, the complex number. That's what convention has. Where did you get that from? You're imagining things. That's why it's called an imaginary number. It's 0. It's staring at you right in the face. It's 0. 0. Anyway, that concludes my talk. But remember, you get the mathematics right, and you'll be able to see where, like, for example, now you're trying to describe gravity. You can't see it. You can't see. You made a fundamental error right here. You'll never be able to see it. Yeah? There's mysteries in this world that where at our level it's right, but at a different higher level it will become wrong. Even Newton's laws of motion. Einstein stated that when you get to towards the speed of light, they violate Newton's laws of motion. Even the law of quantum entanglements violates Newton's laws of motion. Yeah, so there's a fundamental error here we need to correct. Yeah, before we can move on. Otherwise, we're gonna enjoy this period where we think our mathematics is right, and then as we become more and more advanced, there will come a time where it is so wrong we can't see any farther. Yeah, that's all I wanted to add. Yeah, be careful out there. There's a lot of people who tell you a lot of garbage.